Hola, somos de Mexico. Welcome back to FGC 101. I'm Santiago and today we're taking our programming to the next level. We're going to build a full drive control program from almost Java using a control hub, a gamepad, and a driver hub. Don't worry if you're new at Java, we're going to go step by step. First, connect your driver hub or your computer to the control hub Wi-Fi network. Open your browser and type in the control hub address. On the page load, click on Onboard Java at the top. We are going to build this program in 3 pieces, a drivetrain class, a subsystem class, and finally our TLIOP itself. Let's start by clicking the plus sign to create a new file. We'll call this one drivetrain, and since it's not an open mode, we'll leave it a regular Java class. The drivetrain class. At the top we have our package line, that just tells the control hub which folder this file lives in. Below that, we import 3 things. DC motor X, which let us control our motors with extra precision. DC motor simple, which we'll use to set motor direction, and hardware map, which connects our code to the physical road. Inside the class, we declare 2 DC motor X variables, right motor and left motor, plus a hardware map variable called hardware map. These are the pieces of the drivetrains in the function. Now let's build the constructor. There is public drivetrain hardware map. This runs the moment we create a new drivetrain object. First, we save the hardware map with this .hardware equals hardware map. Then we connect each motor using hardware.get, matching the exact names we configure on the control hub, right motor and left motor. Next, we set both motors 0 power behavior to brake, so they stop firmly instead of coasting when we let go the stick. And because our left motor is mounted facing the opposite direction, we reverse it. Using left motor.setDirection, DC motor simple.direction.reverse. Drive method. This is the method that actually moves the robot, that is public void drive, with the variables double speed and double turn. We calculate right power as turn minus turn, and left power as speed plus turn. Then we send those values straight to the set power on each motor. The simple bit of math is what let us one stick drive forward and back while the other makes us turn. Now let's handle everything that is in the drivetrain. We create a new class called subsystems. With the same package line and imports for DC motor X and hardware map. Inside, we declare 2 motors, climber and intake. In the constructor, we grab both motors from the hardware map, and we set the climber 0 power behavior to brake too, so it holds its position when we are not pressing anything. The intake doesn't need to hold position, so we leave it as it. Finally, 2 simple methods. Set power climb, which set power on the climber motor, and set power intake, which does the same for the intake. Keeping this separate from our TLIOP file keeps our code clean and easy to reuse. Now, TLIOP. Time to bring all together. We create our OpenMode file that is called myTLIOP and select TLIOP when Onboard Java asks. At the top we import linear OpenMode and the TLIOP annotation, along with a few extras like DC motor simple, and elapsed time. The TLIOP annotation is what makes this program show up on the driver hub menu. Our class extends linear mode, which means our code runs step by step instead of repeating in short bursts. Inside the class, we declare 2 private fields, mDrive of type drivetrain and mSubsystems of type subsystems. This will hold the objects we built in the last 2 steps. Initialization inside run-up mode. Every linear API mode needs an run-up mode method. And that's where everything starts first. We create our objects. mDrive equals new drivetrain hardmap, and mSubsystem equals new subsystem hardmap. This is where our constructors from before actually run and connect to real motors. We send a quick telemetry message, status initialize, and call telemetry update so it shows up on the driver station screen. Then we call wait for start, which pauses everything until we press play button. Once we press play, we enter our while loop, while OPO is active. Everything in here repeats over and over while the match is running. The first line drives the motor, that is mDrive.drive minus gamepad1.left stick y minus gamepad1.right stick x. We negate the stick values because pushing up on a joystick actually returns a negative number, and we want up mean forward. Next, we read 4 buttons from our rep gamepad: D-pad up, D-pad down, left bumper and right bumper, and store them in a boolean variable so our code stays easy to read. For the intake, if left bumper is pressed, we spin inward at full power. If the right bumper is instead, we reverse to split game pieces back out. And if neither is pressed, the intake stops. The climbing works the same way. With the D-pad up raises it, down lowers it, and otherwise is stay put. Held in place thanks to the brake behavior we set earlier. And that's it. 3 files and just few dozen lines of code. We got a fully working teleup with tank drive, an intake and a climber, all controlled from a single rep gamepad and monitored live on the driver hub. Extreme our code into drivetrain subsystem. And the teleup itself might seem like extra work now, but it will make life so much easier as your robot grows more complex. Got questions? Send us a message to our Instagram or check the link in the documentation. See you at Korea!